Greetings. Welcome to Cloud Academy's course on configuring a Google Cloud Platform solution. I'm delighted you've decided to join me on what is bound to be an educational and exciting adventure into the world of Google Cloud. First, let me begin by introducing myself. My name is Jonathan. I'm one of the course developers with Cloud Academy. I work professionally as a technical consultant specializing in DevOps, data engineering, and security. Now, long ago in another life, I was actually a public school teacher. So I love education and teaching, and I am thrilled to be teaching again, only now, teaching technology. This course is designed to be very practical. It's meant for technology professionals, developers, data architects, CTOs, that kind of thing. And the goal is really to help them get a solid understanding of how to build infrastructure using Google Cloud services. This course will also help you to prepare for the Google Associate Cloud Engineer Certification exam. Now, to earn this certificate, you need a good general knowledge of GCP, Google Cloud Platform, the different solutions, how to configure them. You'll also need to be able to use both the GCP web console and the command line. Now, this course will focus mainly on the console, since it's more of an introductory course. But we will also do some work with the command line tools in the video demonstrations. I want to stress, though, that this course will not cover everything that you need for the Associate Cloud Engineer exam. There are 5 core areas of study in that exam, and as you can see from the exam guide, this course is meant to focus on Area 2, planning and configuring a Google Cloud solution. So then, you're probably wondering, what are the prerequisites for a course like this? What do you need to already know to be successful in this class? Well, the answer is not that much. You should have some general knowledge of computers and the concept of the cloud. You should know what a data center is, what is a virtual machine, and understand just the basic concept of hosting, hosting infrastructure as a service. You don't need to be a programmer, but definitely will help. If you have some knowledge of software development, this will help you to appreciate what each of the GCP products actually does. I also recommend having some basic networking knowledge. Things like HTTP and SSL. Knowing what those are will help you to understand the GCP networking products better. So basically, if you've been working around technology for a while, you're probably fine. If you're a moderately tech-savvy adult, you should be fine. So let's get more specific. What are the actual learning objectives for this course? So in this course, there are 3 main takeaways related to GCP. 1, the student will learn to deploy and configure Google Cloud compute resources and understand the differences between each service. 2, the student will learn to deploy and configure Google Cloud storage resources and understand the differences between each service. And then 3, the student will learn to deploy and configure Google Cloud network resources and understand the differences between each service. You notice a pattern there, obviously. In this course, we're focusing on 3 things: compute, storage, network, all in the context of Google Cloud. The lesson content is therefore divided into 3 sections corresponding to these topics. Now, if you master these 3 fields deeply, computing, storage, and networking, then you will have all the tools you need to be, comfortable as an infrastructure developer on GCP. One last thing, though, before we start, I want to encourage everyone to leave feedback. Email support@cloudacademy.com if you have any questions, comments, suggestions, concerns. We always appreciate people taking the time to do that. Now, without further ado, let's get started. In this first section of the course, we're going to focus on Google Cloud compute resources. Now, by compute, we mean virtual machines that can run workloads in the cloud at scale. If you've ever worked with Amazon, you may know EC2, their VM service, or DigitalOcean, their concept is droplets. If you're familiar with either of these, then you already know a little bit about cloud compute. So with Google Cloud, you have 3 main approaches to compute: App Engine, Compute Engine, and Kubernetes Engine. We will explain how each of these work in the next lesson, and then we'll give some advice to help you know which is best for different scenarios. And then after that, we'll follow up with 2 shorter lessons digging into price estimation and planning, and then the virtual machine types. And then the section will end with a video demo of how to actually use all these things. So if you're ready, let's get this party started. Cloud compute is one of Google's core offerings for businesses looking to run their apps in the cloud. It's your foundation, the hardware and CPU cycles needed to actually run your software. Now, under the compute umbrella are a few different specific services and configuration options and products. For our purposes, though, we are going to focus on 3 main offerings: Compute Engine, App Engine, and Kubernetes Engine. And we'll briefly mention Cloud Functions and Cloud Run. I'll start by giving you a quick high-level distinction between these 3 main offerings. So Compute Engine is for deploying virtual machines, or VMs, much like Amazon EC2. App Engine is a serverless compute product for running code without thinking about VMs. And then Kubernetes Engine is for, you guessed it, running Kubernetes workloads for customers that need container orchestration. So let's dig in a bit more on each service, starting with Compute Engine. As I've said, it is analogous to Amazon's EC2, but let's get a little more specific for folks who may not know AWS. Compute Engine is for deploying virtual machines. You can create a variety of virtual machine types with different amounts of CPU, storage, memory, network bandwidth. You can create VMs in different physical regions, as Google Cloud has data centers all around the world. And then regions have names denoting their location, like US West 1. Each region can have multiple zones, like A and B. So a full location name for a compute resource for a VM could be something like US 1 C, which denotes both the region and the code. So a region is usually a part of a country, like US West or US East. Now, Compute Engine offers a variety of predefined machine types with different operating systems and configurations to match different workloads. There's also the possibility of creating custom machine types if needed, if you need a specific hardware, CPU, memory setup. Billing for these virtual machines is done by usage per second, so you only pay for exactly what you use. And there are also discounts for sustained usage and sort of commitment-based, committed pay up front, sort of commitment-based, long-running jobs. And the lesson after this will cover machine types in more detail, and that lesson will also cover pricing in more depth. Now, let's switch over and talk a little bit about App Engine. App Engine is similar to Amazon's Fargate service. App Engine is designed to let you deploy software without managing individual servers. Instead, you pick an environment and a runtime. Runtimes are language-specific, minimal container configurations. They're runtimes for things like Python 2.7, Python 3, Java, PHP, Node, Ruby, Go. The App Engine environment is the underlying hardware. And when it comes to picking an environment, there are 2 types of environments you can choose. There's the standard environment and there's the flexible environment. So the App Engine standard environment only supports very specific language runtimes. You can't modify the environment after the fact. You can choose an instance class, which will allocate a certain range of CPU and memory and auto-scaling ability. However, you can't SSH into the instances. It's more fixed. In essence, you can think of the standard environment like a sandbox. It spins up quickly, and it can auto-scale pretty effectively, but the main trade-off is limited ability to alter the environment over time. And then, by contrast, there is the flexible App Engine environment. Now, this does let you modify the runtime via Docker files. So if you know Docker files, you know they're pretty flexible. You can do a lot there. You can set up SSH access. You can run pretty much any programming language. You can access other Google Cloud resources and Compute Engine instances within the network. So in short, the flexible environment does less for you, but it gives you more control. And then the third main Google Cloud compute service is GKE, Google Kubernetes Engine. If you're already running or planning to run a Kubernetes application, GKE is by far one of the best ways to do it, as Kubernetes was actually originally designed by Google. So it's a first-class integration. The GKE platform gives you a very powerful API for managing a Kubernetes cluster. You can do this in the console or via CLI tools. You can quickly get information about the cluster, change config, scale pods, alter the access controls, do all kinds of administrative tasks. Kubernetes in general is known for being one of the most powerful container orchestration frameworks available, but it is also known for being fairly complex, tough to debug. GKE removes much of this pain. With GKE, you do almost everything in the console with a mouse. You get fantastic documentation, you get tutorials, you get quick start guides, and you get very good instrumentation and logging. GKE runs on top of Compute Engine. It's using VM instances as GKE nodes. Now, node is the Kubernetes term for a single compute resource. It's very easy to get GKE to intermingle with Compute Engine resources if necessary. If part of your application is in Kubernetes and part of it isn't, if they're all within Google Cloud, it's not a problem to get them to work together. Now, actually, teaching Kubernetes itself is out of scope for this course, but we will spend a little time covering how to create a cluster in the demo. We'll touch on it briefly. Now, finally, I want to mention two other lightweight GCP compute options that are available for specialized use cases, and these are GCP Cloud Functions and GCP Cloud Run. Cloud Functions are analogous to Amazon's Lambda service. They let you define single-purpose, standalone functions that respond to specific events. Now, this is, again, a serverless compute option, and it can work well for circumstances where all you want to do is run some specific function in response to an event that it's watching. So, kind of a targeted use case there. Now, Cloud Run is also a serverless option like Cloud Functions, but the difference here is that instead of running just code, you create containers. Now with Cloud Run, you invoke stateless containers using HTTP requests, or you can have them be generated in response to specifically monitored events. Now this is a very simple way of creating container-based workloads with all considerations of hardware abstracted away. You don't think about even an environment like with App Engine. Now, as of the creation of this course, Cloud Run is still in beta, so we're not going to spend a lot of time on it, but it is definitely worth checking out. So, Compute Engine, App Engine, Kubernetes Engine, your three main purposes. How do I know which to select when working on a Google Cloud application? It's probably easiest to start by thinking about GKE. If you're already using Kubernetes locally or with another cloud provider, then I highly recommend migrating to GKE. Creating a cluster and provisioning needed storage and compute resources takes seconds, and you should be able to reuse much of your existing configuration. Compute Engine and App Engine are great options for everyone outside of the Kubernetes ecosystem. When it comes to these two services, the real question is, how much control do you need? Maybe you like to have root access to your machines by default, or maybe you're migrating from EC2, or maybe you have an unusual environment not easily supported by App Engine. In the base case, I would recommend starting with Google Compute Engine. App Engine is generally a better choice for an earlier stage project, particularly if you can use the standard environment with its various language runtimes. The App Engine flexible environment is more of a niche solution for scenarios where, for whatever reason, you don't want to use Compute Engine, but you don't get enough control from the standard environment. So that's it. At a pretty high level, you now know enough about GCP compute offerings to be dangerous. You can differentiate GKE, Compute Engine, App Engine, and you should know a little bit about Cloud Run and Cloud Functions. You should be able to pick what is best for a given project. Very cool stuff. So in the next lesson, we'll take a deeper dive in VM instance types. We'll learn about cost and hardware optimization as we tour Compute Engine's menu of options. See you there. Now, in this lesson, we're going to go over the various types of virtual machines you can launch in Google Cloud Compute Engine. Our emphasis here will be on cost savings and usage. So as we discussed in the previous section, Cloud Compute offers a range of instance types based upon our app's resource needs. We could also choose from a variety of Linux operating system flavors as well as Windows. Now, as far as hardware goes, there are three main families of instance types. There are compute optimized, memory optimized, and sole tenant. Compute optimized instances offer the highest performance per core with a range of options going up to instances with 416 virtual CPUs. Now, memory optimized instances are for memory intensive workloads. You can get up to several thousand gigs of memory in a single VM if needed. And then finally, there are sole tenant offerings that isolate your VMs and workloads on their own physical servers. So see the documentation for a more detailed list of the exact instance type names, but these are the three basic categories. Now, by default, your cloud compute instances are billed based on uptime. The cost is calculated per second, and the price is largely based on the instance type. However, region also plays a factor. So, for example, an instance with a lot of memory will cost more than one with very little. Instances in US East 4 Virginia might cost a little more than instances in US East 1, which is South Carolina. Usually these region price differences are fairly small, but it's good to be aware of them. Now, so far we've been talking about standard on-demand instances that are created upon request. There are actually two other types of instances that we need to consider to fully understand cloud compute, and these are custom machine types and preemptible VMs. So let's start with the former, custom machine types. Now, even though GCP, Google Cloud Platform, it offers a wide variety of Linux operating systems and Windows VM types, sometimes we want to get really specific about memory and CPU configuration for our workload. So for example, we may find that GCP's high memory instance types have more CPU than we need, or vice versa. Maybe we need a lot of CPU and little memory. With the custom machine type option, you can actually specify the exact amount of memory and the exact amount of virtual CPUs, provided it's an even number. You need an even number of cores. Now you can do this with a single command. Here's an example here. gcloud compute instances create my VM. You just do -- custom CPU -- custom memory. There are many different operating systems that are compatible with the custom machine type API. You can pick Debian, CentOS, OpenSUSE, Ubuntu, Windows is also an option. Whether via the console or the command line, custom machine types are straightforward to set up and launch for workloads that need them. Now, we should talk a bit about preemptible VMs. These are very interesting. These are actually short-lived VM instances that run for up to 24 hours at a time. Now, the upside, because they're so short-lived, is that they are extremely cheap, up to 80% less than a regular VM. Now, the downside here is that they are not suitable for any kind of fault-tolerant workload. With preemptible instances, you don't know when they might die. They're guaranteed to shut down within 24 hours. You can create a managed instance group of preemptible VMs if you want to try to keep a certain number up and running. However, the thing is, preemptible VMs come from excess GCP compute capacity. So because of that, there's no guarantee that a certain number of preemptible VMs will be available, particularly if you need a specific type. So, for example, you might have a managed instance group of 30 preemptible VMs, and maybe they'll run for a while, but if there's not sufficient capacity in that GCP region, you may be down to only 20 instances for a while. You might just lose 10 of them. And because of the inability to guarantee availability, preemptible VMs are not appropriate for any use case that requires consistent uptime or stability. They're great for batch processing, short jobs that can tolerate instances coming and going. And also note that preemptible instances are available for predefined instances and for the custom machine types that we talked about a minute ago. By combining a custom machine type with a preemptible VM, you can really optimize your costs for fault-tolerant jobs. Preemptible VMs are not the only method for controlling costs. There are actually two other really important discount options available on GCP. These are sustained use discounts and committed use discounts. Now, the latter, as the name implies, committed use, is a discount for paying for a certain amount of usage time upfront. Now, this is similar to like Amazon reserved instances. With committed use contracts, you can pay up front for 1 year or 3 years of compute service and get a discount of 50 to 70% of the cost. And actually, when I say pay up front, you don't actually pay the full year or 3 years cost right away. The billing is actually still done monthly. So you don't have to worry about some huge, 3 years of compute paying up front. You pay monthly, and, if you stop using the instance after 6 months, you'll still get billed for the full year. But it's still a really great option if you can actually plan ahead with your infrastructure and you know that something's going to run for a year or 2 years. This is the way to save money. And because you get a 50 to 70% discount. So on top of that, there's also something called a sustained use discount. Sustained use discounts, these kick in automatically if you run a VM instance for a certain percentage of time over the course of a month. So for example, you can get a price cut of around 10% if you run an instance for more than 25% of the month. And if you run that same instance for 100% of the month with no break, you can get up to a 30% discount in the cost. Now, I'm using a little bit imprecise language. These are kind of rough amounts because the exact discount varies a lot by instance type. But in general, the more you run your instances, the bigger the discount. Sustained use discounts are really great because you don't have to think about them at all. They apply to custom machine types as well, and they kick in automatically. Now, the only exception, the only instances that do not get sustained use discounts are App Engine flexible environment instances and also Cloud Dataflow VMs. Very specific. If you use Cloud Dataflow, it's not applicable for sustained use discounts. So with this combination, with preemptible VMs, with sustained use discounts, with committed use discounts, you have 3 really good ways to save money on GCP. Consider your workload to identify which is best for you. Do you only need compute instances for very, very small periods of time? If so, definitely go with the preemptible VMs. Very, very cheap. If, by contrast, you know for certain that your instances have to run for a year or longer, then the committed use discounts can cut your bill in half, no additional upfront cost. And if you can be certain of either of these scenarios, if you can't be certain of either of these scenarios, well, then take solace in the fact that there are automatic sustained use discounts that kick in, without any effort or decision making on your end. So we will stop there. You should now have a good grounding of GCP instance types and cost optimization. Go you. Congrats. Now, to help you save even more, we'll go over the GCP Price Calculator tool in the next lesson. See you there. Google Cloud Platform has probably the best price planning tool available compared to any other cloud provider. And I'm not being paid to say that. The reason we're doing a separate lesson on pricing is largely because their price calculator is really good. It's very flexible, and it's a very good place to start when planning a GCP project. So the first thing you'll notice about the calculator web app is that it breaks out everything by product. You can select everything from Compute Engine to App Engine, storage products like Data Store, everything in between. Just about every single GCP product is selectable, and for each one, you can completely describe what sort of component you want to add to your system. So, for example, we can go to the Compute Engine tab, we can go in there, we can select an instance type, region, instance count, time commitment, several other options, and then after that, once we have a thorough, detailed view of our compute architecture, we click Add to Estimate, and we immediately get a monthly cost. Now, the cool thing is you can do this for several services or multiple times for a single product. So you can actually name each component, which is kind of cool. So you can have a breakdown with something like dev environment storage and production environment storage, where you have multiple instances of storage products, or the same storage product. And then you can add like test environment GKE and see each component broken down by price in the tool with a grand total at the bottom. Now, estimates, once they're generated, you can save them by clicking Save Estimate, and this will generate a link that you can share with people, your team or whoever you need to. There's also an email estimate button that you will, as you guessed it, it'll email it to an address of your choice. These are 2 nice little quality of life features that help you share and preserve estimates. It's particularly nice if you have a really complex architecture that you're proposing and you need to share with a lot of different people, a lot of specifically configured products. One other handy thing about this GCP pricing tool is that Google Cloud actually exposes an API for querying pricing data. And on top of that, there's actually a simplified web page as well if you just want to see a text list of prices. So for the API, this is really good for tooling. For example, if you want to create a script that generates reports or tracks prices, you can use the API along with the Google Cloud CLI tools and or the libraries, and it'll do that for you. The GCP SKU web page, by contrast, is really just a simple search page with a list of prices by service. So this is helpful if you just want to get a general sense or show it to someone, basic prices by service. So in the demo video, we're going to go a little bit over the pricing calculator. It's fairly intuitive, but we'll show you how to run through a couple of simple scenarios, generate a few different estimates for different use cases. And that's basically it. Now you have some knowledge about pricing tools. We're ready to go into our practical demo. It'll be a lot of fun. We'll see you there. Welcome to the first of 3 practical demonstrations on how to use Google Cloud Platform. In this first demo, we're going to do a few things to get you familiar with GCP generally. We'll start by quickly going over the web console and the Cloud Shell. We'll show how to set up your first project. These things will help you get a general sense of how to interact with GCP services. And then after that, we'll take a quick look at the GCP pricing tool. We'll run a few estimates for a few services. And then lastly, we'll take a closer look specifically at compute services. There we'll take a look at App Engine, Kubernetes Engine, Compute Engine, and even run through the process of launching a VM. So to get started, you can go over to console.cloud.google.com or just cloud.google.com. If you don't already have a Google Cloud account, you can set one up from there. All you need is a Google account of some kind, like a Gmail. And it can just click through. You can set one up very quickly, and you can even get up to $300 worth of free service. So here we're just going to go ahead and click on console, and that'll load in a sec, and we can see all of our different GCP services here. We can kind of scroll around and see the different options here. Now, one important thing to note is we can't actually do anything with these services until we have a project to work with. So if we click on this, it's going to say create a project. It's going to put you through that first. GCP expects everything to be contained within a project. So we can go ahead and create a project. We'll give it a name. We'll just call it test project. Create. And this will generate it for us. And projects, these live within an organization. So GCP also expects a name for your organization. We're just going to leave the default for that. And if we give it a moment, it will create. So we can see here the dashboard will come up after the project is created. It should only take a few seconds. And we can see basically test project with an ID. Now, for most of our demos, we're going to use the GCP web console. As you can see, it's got a pretty nice UI. It's very easy to navigate. However, there are situations where we might want to use a command line. And now there are 2 ways we can use a terminal with all of our GCP services. One method is to set up the Google command line tools on our local machine, like a MacBook or a Linux desktop, or whatever we use for development work. And this requires installing the tools and setting up the credentials to authenticate to GCP. We're not going to go through that here. We'll include links with instructions if you want to do things that way. There is an easier method, though. The easier method for using a shell is to just use GCP's built-in Cloud Shell tool. It's right here in the top right of the page. Now, you just click on this once, and we can hop right into a shell environment that will have all of our necessary G Cloud tools and credentials pre-configured. So yeah, just give that a second to provision. So yeah, it might take a few minutes the very first time you use the shell, the cloud shell. It has to spin up an instance for it to run, but eventually you'll get this nice little prompt right here, and you can see it's like any terminal environment. It has our G-Cloud tools already installed, so this is just kind of the default output there. You can look around a little bit, queue out of it. But this allows us to do, run scripts to basically do anything we would want to do in a shell environment without having to worry about setting things up on a local machine. So very helpful. Now, before we start actually spinning up any resources or creating anything, we might want to get a sense of what it'll cost us. So let's take a quick look at the pricing tool. Now, remember, we don't actually have to be logged into GCP to use this. We actually just go to this link here, google.com, cloud.google.com/pricing. But it's useful, of course, to have the pricing and the console open at the same time, so we can kind of check things out before we create anything. So we can just go here to calculators, and let's run through a very basic scenario. Let's say, for example, I want to create a single VM. So here we have our tool, and we're going to start with compute engine. That's already selected, and then it's going to ask us to fill out some basic information. So a number of instances. We'll say 1. What are these instances for? This is really just labeling, so we can just say tests. Operating system, we can be more specific, but we'll stick with one of the free ones here. Free Debian, CentOS Core OS, Ubuntu. Machine class, we're just going to go with regular. Here is where you can also select preemptible if you want to get that for your estimate. Machine family, so as we mentioned, there are compute optimized, memory optimized, and general. We'll stick with general. We'll just stick with first generation. We'll go with a micro. Really all the defaults here. And once we're good, we can just click add to estimate, and it pops right up. Total estimated cost here per month. So pretty straightforward. Now let's say I want to add something to this estimate. Let's say, okay, I want to add a database of some kind. So we go up here, we look for the relevant service. Let's say we want to do Cloud SQL. So we go here. Note we still have this estimate as well. It lets us aggregate everything. But let's say we want just the default here. We want one Cloud SQL instance. There's some configuration we can change here, but the only thing it really needs, you can select a high availability and location. We're going to select all the defaults. The only thing we absolutely have to put in here is a minimum storage amount. SSD, we're going to say 10 gigabytes, and keep all the other defaults. Hours running per day, days per week. We'll add that to the estimate, and we can see this is a little more expensive than the VM, but yeah, $13.25 per month. So this is your price estimation tool. It's, as I said, it's pretty straightforward, pretty intuitive to use. So that's the pricing tool. Now we're going to go ahead and try to create a virtual server. So here in the list of services, we can see the compute section here. We've got App Engine, Compute Engine, Kubernetes Engine. We have Cloud Functions and Cloud Run. More lightweight abstracted services there at the bottom. And what we're going to do is create an instance inside of Compute Engine. Now you can see, just to give you a sense of what it looks like, Kubernetes Engine here, we can click on it and we can create a cluster. So this is, if you're familiar with the Kubernetes paradigm, this will generate your cluster and will create the nodes on top of which your container orchestration will run, your cluster. If we go back, we can pick App Engine as well, which is our serverless solution. And here, the tutorial, it takes you through creating an application. If you start going through it, it'll ask for a region, and then eventually it'll ask you to select a language runtime and the type of environment. As we mentioned, there's the standard and there's the flexible. So that's App Engine. We're not going to make anything with those, but what we'll do is we'll go here into Compute Engine, and we'll go through the simplest case, creating a single virtual machine. So we just go through our quick start guide. We can click on Create Instance. It's going to ask for some basic information about it. We're going to, again, stick with all of our defaults. We'll just call it Instance 1, so in US Central, general purpose, first generation, 1 vCPU, 3.7 gigs of memory, very, very lightweight. Again, all defaults. And we'll just click Create. And just like that, we have our first virtual instance up and running. And of course, we can do this with the shell as well, and we can be a lot more specific with the configuration. But as you can see, just getting a compute resource up and running is pretty straightforward. So I think that's where we will stop with this demo. In the later sections, we'll go into more depth on storage setup and networking. But with this, you should have a general sense of how to get started with GCP, how to get into the console, set up your project, and interact with the compute services. So I hope this has been beneficial. Welcome to Section 2 of our course on configuring a Google Cloud Platform solution. In the previous section, you learned all about GCP's various compute offerings. However, it's likely that you'll need to do more than just computation in your application. You'll probably want to store data somewhere for later retrieval. That is what this section is all about, storage. GCP offers a number of storage options, from managed SQL to column stores to in-memory only caching systems. In the next lesson, we'll do a broad survey of each of these options. Then in the lesson after that, we'll offer some insight into how to choose the right storage solution for a given use case. So without further ado, let's dig in. Google Cloud gives you a lot of ways to store your data. There are a variety of managed services that handle infrastructure, scaling, backups, all of that for you. And then there are more configurable approaches for people that want to directly administer everything. Probably the easiest way to break it down is to make a distinction here between storage and databases. So when we talk about databases, we usually mean data stored with a certain structure. The database has storage, of course, but the key thing is the software for accessing it. Storage is the more generic term. Google Cloud has 5 distinct offerings for simple storage without any concern for structure or database software. So as mentioned, the first is VM attached persistent disk storage. Now this is analogous to an Amazon EBS volume. This is a block of HDD or SSD storage that's attached to individual compute engine instances. Now this is a great solution if you're doing a monolithic app on a single server and you need all of your data in one place, possibly a database engine running on that instance. 2 really nice features about GCP's persistent disk storage is zero downtime scalability and automatic encryption. So you get the peace of mind of knowing that your data is secure at rest, it's encrypted, and it's very easy to add more storage to an instance without interrupting anything. Now, GCP also has an NFS storage product called Cloud File Store. This is similar to persistent disk. You can mount NFS instances onto VMs for applications that need a file system interface. This is a type of NAS, or network attached storage. So the critical thing to consider here is latency. File Store offers 2 different performance tiers. There's a standard performance tier and premium. So the main difference here is that the premium tier offers substantially higher read-write throughput. So be sure to check the specs here very carefully. We'll add a little chart you can look at. And, there are many applications, of course, that can be bottlenecked by NAS systems. So the 3 remaining GCP storage products are all very similar. They are all managed object storage systems similar to Amazon S3. The difference between these 3 products concerns the frequency of access of the things that you're storing. So the names of these products in order of greatest flexibility but highest price, they are Cloud Storage Nearline, and Cloud Storage Cold Line. So all of these products, the cloud storage, they work using buckets. That's the standard approach. We create a bucket in the console or using the command line, and in these buckets we can store any arbitrary data we want. And again, like S3, we can set all kinds of security configuration on the buckets. We can integrate them with our applications. We can make them publicly available. We can grant access so that things can read and write from cloud storage. The only thing different about the nearline and the cold line versions of cloud storage are the access frequency SLA and the cost. So nearline is for data that is accessed relatively rarely, say once a month. And because of that, it's much cheaper than just the regular cloud storage. Now, cold line is really for archiving. This is by far the cheapest cloud storage you could get, but with its access SLA, it is really only for data that's accessed maybe once per year, if ever. So cold line is a really good place to dump log files, compliance records, noisy metrics, debug files, redundant backups, other data that might only be relevant in a really unusual kind of disaster scenario. So those are the basic, raw storage methods for VM instances and for other GCP services. You could use file store or persistent disk if you need to attach storage directly to a server. And now you should know a little more about cloud storage as a solution for managed storage buckets. Now, for most applications, though, we're going to need some structure to our data. We need more than just a bucket. We want to run SQL-like queries. We want an SQL-like interface or some sort of query language. We want a proper database solution. And for that, GCP offers 5 distinct products again. So let's start with the more popular offering, and that would be Cloud SQL. Cloud SQL is analogous to Amazon RDS. Again, sorry with all the Amazon comparisons, but it's the easiest way if you're familiar with it. So what Cloud SQL is you create database instances, similar to VM instances, in your account in specific regions. There are actually a few different flavors of Cloud SQL, 3 different ones. There's a MySQL one, a PostgreSQL one, and a vanilla SQL type. So this is just depending on the type of SQL engine you want to use, based on your preferred SQL implementation. All versions, though, include the same basic features: automatic encryption of data at rest, seamless scalability for adding read replicas, and multi-region support. You can add more CPU and more memory for tougher workloads. All of that is supported. Now, Cloud SQL is not the only relational database offering for GCP. There's also something called Cloud Spanner. And Cloud Spanner is actually a very interesting product. It's a very interesting SQL solution in that it tries to give you all the benefits of a traditional relational database without any of the trade-offs demanded by massive scale. So if you've ever studied CAP theorem, CAP, you might know the old saying that there's consistency, there's availability, and partition tolerance, and you can only get 2 of those things. So you have to pick 2. So if you want consistency and availability, you have to sacrifice partition tolerance. If you want partition tolerance and availability, you have to sacrifice consistency, so on and so forth. Cloud Spanner is a product that tries to break this rule and give you all 3. And it does this by throwing hardware at the problem. So the trade-off is price. So let me be a little more specific. With Cloud Spanner, basically, you get high availability, strong consistency, and the ability to scale horizontally. And this last point is accomplished by adding nodes. So nodes are compute resources that can be configured as part of your Cloud Spanner setup. What they do is they add CPU and RAM resources to your Spanner database, and they allow you to ensure strong performance even across many geographic regions. So with Cloud Spanner, you can have a massive amount of traffic, literally thousands of writes and reads per second, with strong consistency guarantees. You get, classic relational ACID guarantees and guaranteed availability across the globe with guaranteed performance using an SQL-like interface. So basically you have your cake and eat it too. You have everything. Now the trade-off, as we said, is price. Generating the necessary amount of nodes and replicas will not be cheap. Now check the GCP pricing tool here for more details. Here's a quick example just for reference. As you can see, for a small workload, a single node in a single region, the Spanner deployment is actually an order of magnitude more expensive than Cloud SQL. Now, in general, Cloud SQL is going to be much cheaper and is the more standard approach for a managed SQL solution in GCP. Cloud Spanner is really for more unique use cases, very unusual use cases. So be sure to look into that, the documentation there. Now, GCP offers also two distinct NoSQL databases. One is called Bigtable and one is called Firestore. Now, the former, Bigtable, is a wide column database, and the latter, Firestore, is a document database. So if you have worked with like Cassandra or MongoDB, CouchDB, maybe you are familiar with NoSQL systems, you might know a little bit about kind of the use cases and the problems they're meant to solve. Column databases tend to be great for more write-heavy workloads, such as scan data, time series data. Document databases are often used for JSON or unstructured text. So again, these are for particular use cases. And then finally, we have the memory store and Firebase. Now, memory store is simply a managed Redis service. This is for storing data in memory on customizable nodes. It's generally used as a caching layer to speed up read performance, kind of like Elasticache again in AWS. However, it can also be used as a data store in its own right if you want to have all of your data just in memory. Firebase database is a real-time syncing database that stores data as JSON documents. It's used often in mobile applications that need to keep client data in sync. So Google acquired Firebase, as you may know, several years ago, and tightly integrated the Firebase database product with GCP. This is distinct from Firestore. So, be sure to look at the documentation there. If you're familiar with Firebase, this is the GCP version of it, and it's definitely a great option if you're already using Firebase. So, okay, that's it. Well, that was a lot, and thankfully we're done. We've covered all of the main GCP data storage options. You should have a good understanding of each, but maybe not enough to make strong recommendations for a specific use case. So, in our next lesson, we'll cover that exact issue. We will talk very specifically about which storage technology you should choose. We'll talk about them generally, and we'll relate them to specific GCP use cases. So when you're ready, we'll see you there. Cheers. Now, choosing the right data storage technology is absolutely critical for developing a performant, scalable cloud application. Many great app ideas and startups have struggled due to bottlenecks and data management issues caused by using the wrong database. So our focus here is databases, not pure storage per se. We're not going to worry about GCP persistent disk or file store. Google Cloud Storage, the service, can actually be used as an application data layer or database if you want, but it's generally not as good as a proper database that structures data in a predictable way. So we're going to focus on GCP's dedicated managed database offerings. So when choosing a storage technology, there are really 4 critical issues to keep in mind. 1, what is the data model? 2, what are my access patterns? 3, what is the expected amount of data now and into the foreseeable future? And then 4, are there any external constraints around cost, compliance, data location, etc.? So data model, that's our first consideration because it's most likely to cause suffering if we get this wrong. If we get the data model wrong, we're going to suffer later on trying to fix it. One example of that, if you opt for a technology like Cassandra, column database, and you need to support a variety of complex arbitrary read queries on your data, you're going to have a bad time. It just isn't meant for that. So deciding between relational versus NoSQL, that's a good place to start. If you're dealing with, again, time series data, scan data, JSON documents, binary blobs, there are a number of technologies particularly suited for those use cases. You might want to look at Cassandra, MongoDB, and then in Google Cloud, there are versions of that. Bigtable, for example. Now, consider also access patterns here. And here we have to consider several different factors. Do we expect to mostly write a lot of data without doing many reads? Or perhaps the inverse of that? Perhaps something more balanced? Do we have a strict SLA that requires very fast data retrieval? Do we need to support access from many different regions? Do we need some sort of caching strategy, either through hardware and database options or an additional technology like Redis? So this question of access patterns is very, very important. And then the third consideration is data volume and growth. Now, here we need to consider the expected data size both at inception and over time. And this can be a very hard thing to predict. So it's good practice to overestimate. So, for example, if you're starting with, say, 10 gigs of production data and expect it to grow to 100 gigs in a year, that's your expectation, then you want to plan for at least 1 terabyte of data or more. This will ensure that you're ready for unexpected usage spikes or application behavior, some, spike in log files, something like that. We need to account data volume and growth both for budgeting purposes and for our operational concerns. We need to know how difficult it is also to increase storage capacity. Some solutions, it's easier to increase storage than others. And then finally, we need to think about, the non-technical factors, regulatory issues, legal requirements around data, and of course, budget. So in some countries, for sensitive industries that deal with personal data, there may be requirements that data be encrypted and stored within a specific geographic region. These issues need to be accounted for upfront because, again, they can create huge operational headaches and even get a company into legal trouble if they're ignored. So now, how do we take these 4 considerations and then apply them to the GCP storage technologies we've introduced? So let's start with data model. GCP Cloud SQL is a great option if you need a robust, managed relational database service. You can, of course, just set up your own database instances on a compute engine VM, but then you don't get the same strong uptime guarantees, built-in security, backups, upgradability. It's a trade-off of more fine-grained control in exchange for more operational overhead. And then, of course, Cloud Spanner is another great SQL option if you need global scalability and can tolerate a little bit more latency and cost. Now, if you're in the NoSQL world, then you have a couple of things to consider in GCP. You have Memory Store, which is a Redis service for low latency and very fast in-memory storage. Depending on your use case, it may be your main storage engine, or it could be a caching layer in your architecture. And then you have Cloud Firestore as your document DB option, and Bigtable, which is your column-based storage offering. So consider your own app's data model and determine which of these makes sense as a good fit. And then we have to factor in access patterns. Now, we should be able to narrow down our range of choices by considering data model first, and then thinking about whether our workload is going to be read-heavy, write-heavy, balanced, or something else. So we need to consider what sort of queries we need to support. What latency can we tolerate? Whether or not we need to support multiple geographic regions. So, for example, there's the case of Cloud SQL versus Cloud Spanner. The latter is a clear choice if we need global support access, and the former is a clear choice if you want the lowest possible latency, particularly at the regional level. And then, the third consideration, data volume. Well, for GCP products, we might think about an in-memory solution like Memory Store. This might be super fast, but it can be expensive and painful to scale if our data grows by several orders of magnitude. And the best way to make this decision is to use the GCP pricing tool, of course, and get estimates for different storage technologies at very large amounts of data. And this should help future-proof your choice from a cost perspective. You also need to consider the difficulty of increasing storage. Cloud Spanner and Bigtable in particular are very easy to grow if necessary. So this last consideration, more nuanced, compliance, regulatory issues, budgeting, these non-technical issues can cause major disruptions if you don't account for them. So the nice thing about GCP storage solutions in general is they're very flexible. For example, all of these solutions support multi-region in different ways. All of them support access control, encryption, detailed logging, and auditing. If you're in a sensitive industry like healthcare and finance, it's still a good idea to do a more thorough deep dive on the documentation, just for whichever solution might seem like the best fit. So that concludes the second and final lesson in our section on GCP storage. You should now have a solid understanding of the major offerings and should be able to determine which is likely the best for your use case. Congrats on making it this far. In the last part of this section, we'll do a demo. We'll walk through planning and implementation of a storage solution in the web console. It'll be a blast. See you there. Welcome to the second practical demonstration on using Google Cloud Platform Services. This video will focus on using GCP storage products with the web console and the command line. We're going to do a couple of things. First, we'll just do a quick survey of the different products in the console so you can kind of see what it looks like. Then we'll actually go ahead and create some storage. First, we'll create cloud storage buckets using the web console and the command line. And then after that, we'll go ahead and create a cloud SQL database instance and configure it with some specific settings. So first, let's just look around the console generally. You can see here on the left-hand side, we have the storage section. So we have Big Table, we have Data Store, and Fire Store, and File Store, SQL, Spanner Memory Store. Here in storage, this is for all of the cloud storage products, including nearline and cold line, and the different, depending on archival and access patterns. And then we have File Store, which is kind of the NAS version of that, a network attached storage version of that. So this is basically where things are. We can click around a little bit and see, for example, Big Table. We don't have any instances running now, but you could run through the Create Instance wizard to actually see what that looks like. We can do that with all of them. I mean, they're all pretty straightforward here in the console. We're not going to create everything now, but we can kind of see how things look. So let's move on. Okay, so now let's go ahead and actually create a sample bucket in cloud storage using the command line. Now we're going to use the cloud shell. You click on this icon here in the top right to get it to work. I already have it running. Be aware, again, the first time you click on it, it might take some time to come up. So as you recall, you have your tools already installed in this little environment. So you can see gcloud command line. We should get some output there. And what we're actually going to use is gsutil, the other command line tool. And so to create a bucket, we're going to do gsutil make bucket, and then we have to give it a URL for the bucket. We do gs:// we'll just call it Cool Cloud Academy bucket. And from entering that command, it'll go ahead and it'll create our storage bucket. And we can go into the storage UI here. Oh, sorry, that's SQL. We want to go to cloud storage here. And we should be able to see our bucket right there. Cool Cloud Academy bucket. Now, this is one way to create a bucket. You'll see here that because we didn't add any arguments, it created a bucket with all the defaults. So by default, it's multiple regions in the United States. Public access is per object. There's no lifecycle enabled. There's a whole lot of default things here. And so what we might want to do is change some of that. And to show you some of the different options you have, what I'm going to do is use the web console and create another bucket. So we go here, we click Create a Bucket, and we're going to give it a name. We'll call it Cool Cloud Academy Bucket 2. And then there's a number of options we can add. So there's some estimates here we can put for storage size and data retrieval if we want to worry about that. We click Continue. We can decide if we want multi-region or single region. We can decide if we want to do nearline or cold line for longer term archival. Access control model, what permissions we want to set. We're going to stick with most of the defaults here, but really just showing all the options here. We can add labels, tags essentially. Then when we're done, we just click Create. And once again, we'll see the bucket come right up. So go to our storage dashboard, and there it is, Cool Bucket 2. And now the last thing we're going to do is we're going to create an actual database instance in the console using the Cloud SQL dashboard. So we go into storage here. We have a lot of different options for storage, as mentioned. We just click on SQL, and we're going to create an instance. There's an option here as well to migrate data. And you'll see again, one of the first choices we make is, do we want to use MySQL or Postgres SQL? And we'll go for this, we'll go with MySQL as our flavor. And then once this comes up, we have some options here. Sample, so we'll just call it sample 1. We can set a root password, something bad, don't do that. Some regions, zones, our database version. And then once we're ready, we just click create. And just like that, we will have our instance. We have a database instance ready to go. So the instance ID will come up and some other details. But it is really, really quite simple. We can do this same thing with the command line. But now you should have a general understanding of how to create storage and databases using Google Cloud, using the console or the command line. So thanks for sticking around. It's all well and good to have virtual servers running your applications with top-of-the-line storage and database solutions backing them. Unfortunately, none of that will matter without the right network setup. Your network is the glue that makes everything work together. We're talking things like DNS configuration, secure data transfer, load balancing, access control, VPCs, peering, and overall traffic optimization for a geographically distributed user base. Now, fortunately, GCP offers a plethora of networking services to ensure your application has optimal performance and security. In this section, we'll start by reviewing the core networking products. We'll have separate lessons on load balancing and DNS, since those are particularly crucial. And we'll also talk about resource geolocation in its own short lesson, since multi-region support is one of GCP's strongest characteristics. So if you're ready, let's begin. In this section, we're going to briefly introduce each of the GCP networking services. Networking is a complex topic. There's a lot of room for error if we try to not think about it or make a lot of random assumptions. But fortunately, GCP's solutions are pretty intuitive. Now, it's out of scope for us to explain in minute detail computer networking concepts. So this section is not meant to go in depth on the tooling or the configuration for any of the products. We're just going to give a basic overview on the problems that each service is meant to solve. In the following lessons and the demo video, we'll do a deeper dive on the products most critical to setting up an application and passing the certification exam. So we'll start by talking about GCP Cloud DNS and Cloud Load Balancing. Now, the former is the GCP solution for configuring DNS records for domains that you own. It's not a domain registrar. That's actually a separate Google product. You can register domains with Google. But Cloud DNS, rather, is a means for associating a domain name, like, mycoolapp.com, with the actual servers or endpoints hosting the content. So it's analogous to Amazon Route 53 in AWS or any other domain name servicing company. GCP Cloud Load Balancing is the traffic routing layer. Now, there are many types of GCP load balancers to serve different use cases, such as internal traffic, external internet-facing traffic, SSL offloading, HTTP requests, TCP UDP requests, both Cloud DNS and load balancing. We're going to cover these in more depth in their own lessons, but that's just the basic for those two. Now, the next thing we want to cover are GCP's network peering services. Now, there are a few different ones here, so let's go through this carefully. Peering, in case you aren't familiar, is simply the process of connecting two separate networks so that they can exchange traffic. And there are many business cases where you may need to connect GCP traffic to an internal corporate network or a customer's private data center or some other distinct endpoint. So the two main solutions for this are GCP direct peering and carrier peering. Now, the former works by creating a dedicated connection between your private network of choice and Google's Edge network. And the latter, carrier peering, works through a service provider like SoftBank or Level 3 or Verizon. So in the case of carrier peering, you have a service provider acting as a kind of black box or middleman. And there are a few specific enterprise-level use cases where this can be really necessary. For example, for security purposes, a company might want to expose only a portion of their network to the public internet for accessing GCP services. However, configuring and maintaining a DMZ, basically a perimeter network, that might be too much overhead, particularly for smaller companies. So instead, the company might just go to their service provider, say Verizon, and ask them to create a dedicated link for traffic to GCP. This is the problem that carrier peering can solve. Now, for direct connections to GCP, direct peering is a logical solution. This creates a peering connection between your internal network and Google. Now, there's another version of this, similar, that's even more direct. This is called dedicated interconnect. Dedicated interconnect solution. This is similar to direct peering, but it goes further by creating literally a dedicated physical connection. You set up a co-location facility, and with routing hardware that matches GCP's requirements, you create a dedicated wire connection from your systems to Google's. Very useful if you need an air gap or you need physical control over the infrastructure for whatever reason. Now, on top of this, there's actually another fourth option for situations where you need the dedicated physical connection, but your company's data center, for whatever reason, cannot access a GCP co-location facility. Now, this is a somewhat niche scenario. It's covered by a product called GCP Partner Interconnect, and this is, again, similar to the carrier peering solution in that it works through a third-party service provider. So essentially, you select a service provider from a list of GCP partners. There's a link. We can show you some of the examples. And you use their direct connection to GCP. So you're relying on both GCP and another company's hardware, which may potentially create additional concerns around performance and security. However, it may still be your best option if you already have a trusted third-party ISP and you still need that dedicated physical connection to GCP. So, to review, direct peering, carrier peering, direct interconnect, and partner interconnect. Make sure to keep in mind the basic differences, especially if you're responsible for your business's network or data management. Now, let's move on to two important network security solutions, and that would be Cloud VPN and Virtual Private Cloud. Now, the former is Virtual Private Network Service designed to protect traffic traveling between GCP and some other endpoint. Like any typical VPN, this is a good way to ensure data coming from the public internet is secure before it hits your GCP systems. GCP offers both classic and high availability VPN types, the latter being more restrictive in its configuration but promising a better SLA. Cloud VPN is a simple way of connecting an outside network to GCP endpoints, including a Google Cloud Virtual Private Cloud, or VPC. So let's review that. What is Google Cloud VPC, or GCP VPC? Kind of hard to say, quite a mouthful. Anyway, GCP VPC, what that is a virtual private cloud service within Google Cloud. The virtual private cloud is simply an isolated subset of a larger network with firewalls to block unauthorized access. AWS has the same basic product, VPCs. Generally, a VPC is the key unit of measure for defining your application's network resources. So, for example, a single instance of your app or your database, it might live inside of a single VPC, which is usually within a single data center or zone. And what's unique, actually, about Google Cloud VPCs is that they can actually span multiple geographic regions. So you can have a single VPC with instances on the United States West Coast and instances on the East Coast, and they can still talk to each other without accessing the public internet. This isn't the only cool thing also. With Google Cloud VPCs, you get a built-in integration with Cloud VPN and very easy peering between VPCs and the ability to expand the subnet range of available IP addresses within a VPC with zero downtime. So if you have ever had to deal with any of this stuff, if you've ever had to manually expand subnet ranges in a less full-featured cloud provider, then you'll appreciate a lot of these quality of life enhancements. And suffice to say, Google Cloud VPC will give you the tools you need to manage your app's private cloud configuration. So let's get into some of the more niche networking services, stuff you probably won't need to worry about right away. So we're going to talk about Cloud CDN, Traffic Directory, and Cloud Armor. Now, Cloud CDN is a content delivery network, which maybe you guessed if you know the acronym CDN. It's meant to do one thing really well: cache content near your end users for faster performance. It does this by working with Cloud Load Balancer to cache various types of content: images, video, text, any sort of media at one of its dozens of edge site locations. HTTPS SSL support is built in, so you don't need to worry about performance overhead from encrypted traffic. This is a really great solution if low latency access to content is a critical requirement for your app, given the number of edge site locations they have around the globe. Now, Traffic Director. This is a network traffic management tool specifically for service mesh architectures. Now, the term service mesh may not be familiar to everyone, so, basic summary. A service mesh is an additional software infrastructure layer that controls service-to-service communication. Now, this is only relevant when you have a microservice cloud architecture with many different small software services communicating with each other. Tools like Lyft, Envoy, Proxy are an example of a service mesh product. GCP Traffic Director is meant to work on top of that for even easier service traffic management and load balancing. Again, somewhat niche, not something most people are going to worry about at first. However, as a microservice app grows and becomes orders of magnitude more complex, the service mesh paradigm can become a very useful approach, and GCP Traffic Director makes it easy to manage. And then finally, you have Cloud Armor. This is a DDoS prevention system, and this can be really the difference between life and death for a company. Depending on your threat model, if you're a company that's worried about DDoS attacks, this is something that you're going to want to look at. It may or may not be a major concern for your infrastructure, but if they are, then Cloud Armor is the way to go. It works directly with GCP load balancing. It offers a way to automatically mitigate suspicious load spikes. You can configure IP range-based blocking, even configure blocks for specific geographic regions if you need to. So, okay, wow, that was a lot. Congratulations on making it through. You now know all about the basic networking with GCP, or at least you know enough to sound credible. In the following 3 lessons, we're going to dig in on 3 of the core elements of networking in a cloud provider. That would be load balancing, DNS, and multi-region support. Can't wait to see you there. Distributing network load properly is one of the most important architectural challenges when designing a cloud-based application. Poor choices regarding load balancing can lead to runaway costs, poor app performance, security risks, and a number of other business hazards. So for this reason, it's worth focusing on GCP's load balancing catalog in its own short lesson. There are exactly 6 specific types of load balancers, each designed for a particular type of traffic workload. 3 of the 6 are designed for global load distribution, and 3 are regional. We will start by considering the 3 global load balancer types. The 3 global types are the HTTP load balancer, the SSL proxy, and the TCP proxy. The first is, as the name suggests, meant for HTTP or HTTPS traffic. This is perhaps the most common type of load balancer for a typical web application. It's internet-facing, meaning it takes external traffic on port 80 or port 8080, or 443 for HTTPS, and then it routes that traffic to your backend services. The other 2 global types, the TCP proxy and the SSL proxy, are for more targeted use cases. Specifically, the SSL proxy is meant for SSL offloading. Now, SSL offloading, in case you don't know, this is the practice of decrypting SSL traffic before sending it to some other endpoint. Now, this is an optimization. It's a method for reducing the strain on backend systems by ensuring that they don't have to spend CPU cycles decrypting secure traffic. Now, the TCP proxy load balancer is for TCP connections that are not SSL and not HTTP. This is another global internet-facing load balancer. It supports IPv6 traffic, but one detail to note is that the TCP proxy load balancer will not preserve client IP addresses, so be aware of that if that's necessary. Now, the 3 regional load balancers are ideal for situations where you need explicit control over where TLS connections are terminated, possibly for legal or security reasons. Your options here are the network TCP UDP load balancer, and then the internal HTTP load balancer and the internal TCP UDP load balancer. Now, the network TCP UDP load balancer is the only one of these three that is meant for external traffic. And there are two specific scenarios where this is your best choice over the other external load balancers we described earlier. One scenario is you need to load balance UDP traffic. If you're doing UDP traffic, this is the way to go. And two, the other scenario is that you're load balancing TCP traffic and you need to preserve client IP addresses. So if either of those things are important to you, then you'll want to look at this option. Now, the internal TCP UDP and the internal HTTP load balancers are comparable to their global counterparts, their global external counterparts. They handle the same basic use cases. One is meant for TCP UDP traffic, the other is meant for HTTP traffic or HTTPS requests. The only difference is that they are situated within a private network. They cannot accept requests direct from the public internet. They are instead meant for routing traffic between microservices or within a VPC, for example, or from one compute engine instance to some other backend service or endpoint within GCP. You can, of course, combine multiple types of load balancers in your architecture. For example, you could start with a global external load balancer that will first route a client request that could eventually hit an internal load balancer that targets the appropriate service. This is one approach. Now, to make this a little easier to understand, there's a handy chart that GCP gives us that gives you everything you need to know to decide which load balancer is best for you. And going from left to right, we can see the basic questions we need to ask ourselves about our traffic. Do we need to accept HTTP connections? Do we need SSL offloading? Do we need to preserve client IPs? By going through this flow chart, we could determine which of the 6 load balancer types best matches our needs. So that's all you need to know at a fairly high level in order to pick the right load balancer for your situation. Next lesson, we're going to talk about resource geolocation, and it's going to be a ton of fun. See you there. Now that we've covered the bulk of GCP's network services and reviewed load balancing options, I think it's a good opportunity to take a step back and think about our Google Cloud architecture from a global view. How can we optimize our GCP services in terms of their physical location? What are the best practices around mapping out where our GCP resources will live, ensuring optimal availability, performance, and cost? So in this short lesson, we'll offer some guidance and best practices that should serve both at work and on test day if you're aiming for certification. Now, probably the best place to start is with Google Cloud's global location page. This will tell you which services are available in what region. So obviously, if you already know you need a specific GCP product, it's a good idea to ensure that it's available in the region you want. So for example, as of the recording of this course, GCP BigQuery and Firestore are not available in US West Oregon region. So plan accordingly if that's what you need. The general rule is that for latency purposes, we want to have our cloud infrastructure situated near our user base. So if the vast majority of your users are in the EU, it makes sense to use one of GCP's European data centers, perhaps Zurich or Frankfurt. Sure, your app will still be usable by people outside of Europe, but it might be a little bit slower if they have to cross the ocean in order to hit your data centers. Now, this gets harder to optimize, of course, if you have a global user base. If traffic is coming and going all around the world, then you need to think about how to distribute infrastructure in a cost-effective way. Now, the earlier lessons on GCP storage products should give you enough guidance to know which services are the best fit for global or multi-region use cases. As far as networking goes, hopefully the previous lesson on load balancing offered enough insight to know which GCP load balancer offers the best situation, the best offering for a complex worldwide traffic routing. GCP's Cloud CDN is another important piece of the puzzle, as it can serve as a kind of global cache for frequently requested content. Now, finally, when you're considering resource geolocation, we of course can't forget about security. In general, GCP is good for this, but things like, with things like default encryption and a lot of logging for forensic and performance analysis. However, at the network level, we have to think more specifically about connectivity and access control. Good practice is to use a VPC, virtual private clouds. Remember, they can span multiple regions, so you can have one VPC hitting the data centers in different parts of the world so that your backend services can be optimized. And make sure that your requests are properly authenticated coming through a load balancer. If you need some direct access to part of a VPC, consider using GCP's VPN offering to lock down that connection. So those are some basic tips about planning for a distributed architecture. We could definitely go deeper than this for more unique scenarios, but what we have covered here are the main principles to ensure you know enough to get started. Now we're ready to move on to our last lesson in this section before the demo. That's Cloud DNS. When you're ready, we'll see you there. In this final instructive lesson, we're going to go in depth on GCP's Cloud DNS service. DNS servicing is a critical make-or-break component of any web-facing application, so we want to make sure you understand GCP's approach. So if you've worked with DNS providers before, like Route 53 or maybe GoDaddy or something like that, then you understand the basic purpose. DNS providers let you publish domain names and route traffic to specific servers and infrastructure. So if we have a website running on a random IP address and we want to connect it to our domain, coolsite.com, a DNS provider can create the necessary records to do that. Now this is of course distinct from a domain name registrar service. Cloud DNS is not meant for purchasing domain names, but you can do that through Google, as we mentioned. Domains.google.com lets you buy domains. You can also buy domains from any other service, including Route 53 or GoDaddy, and then configure them using Google Cloud DNS. The DNS provider is actually about doing something with the domain name, not buying it. So Google Cloud DNS, how do we actually start doing things with it? Well, once we have a domain name registered and we're ready to work with it, we start by creating what are called managed zones within Cloud DNS. These are analogous to DNS zones, and within GCP there are two types, public zones and private zones. Both are just containers for DNS records. For example, an A record pointing to an IP address. The difference is that public zones are visible to the public internet, while private zones can only be seen by specifically authorized VPCs, virtual private clouds within a GCP account. So in essence, private zones are not visible to the public internet. Now, you will configure public zones for applications that need to be reachable by users from the public internet. For example, your main website will have a DNS name, and you may create a record in a managed zone config that routes traffic to it. Now, this could be an A record aimed directly at a VM listening for HTTP requests, or perhaps more likely a load balancer that's directing traffic to your site instances. On the back end, you can make use of private zones for traffic within the VPC. So for example, you could have an internal load balancer with internal DNS name that's usable by your back-end services. So now, instead of having to configure IP addresses or have some service discovery layer, you can just use a predictable DNS name internally that's configured within the private zone and have your back-end instances talk to each other that way. Now, that use case may seem a bit complex, and I will say that the ins and outs of DNS routing and traffic configuration, there are other courses that go into that. We're not going to dig into that here. But I definitely recommend reading up on the official GCP DNS, Cloud DNS documentation if you need a deeper dive on these sort of internal use cases. The most important takeaway here is that both public and private managed zones are a part of GCP Cloud DNS. This is your basic paradigm and your one-stop shop for creating DNS configuration and records. We'll talk a little bit more about Cloud DNS in the demo coming up. You'll get to see kind of how it works in the console and how things are actually configured. When you're ready, we'll see you there. Welcome to the third and final practical Google Cloud demonstration as part of this course. In this video, we're going to go over how to use GCP network services in the Google Cloud Web Console. There are three specific services we're going to showcase here: VPC, load balancers, and Cloud DNS. We'll work with an existing instance and see how we can change VPC configuration, such as firewall settings. We'll then create an external load balancer for a backend service, and we'll take a closer look at Cloud DNS to see how zones are created and configured. So let's start with VPC. As we can see on the left side, we have our network services area, and in here we can click on VPC and VPC networks. And then in the VPC network section, we see one called default come up. Now this default network was created for us automatically. It's similar to AWS. whenever you create a VM in Google Cloud, it's by default placed into a VPC for security purposes. Now we can see that this one is configured for multiple regions. We have subnets for every region. And from this dashboard, we can do a lot of different things. We can change firewall rules. We can click on multiple ones that we don't need and delete them if we want. We can generate new firewall rules here. You just click create, and it'll ask for some basic information. Test rule, test tag. Let's say we want for all IP ranges, right? And then, oh, sorry, there's an extra period there. And then we can have additional filtering options for IP ranges. Let's not worry about that for now. We'll just do allow all, and we'll go with create. Now, this is a very open firewall rule, but just to show how simple it is to create, it'll take a while and it'll come up. We can do a few other things here. We can also change our external IP addresses. And from here, we can reserve new static addresses. It's kind of like Amazon Elastic IPs. So we can reserve new ones here and associate them with instances. So basically, this is your one-stop shop for all VPC configuration, this section. Okay, so now let's walk through the process of creating a load balancer. Now, the key thing to remember with load balancers is that they need to be connected to a back-end service, and those services need an instance group. You can also connect to a bucket, but we're going to do a service since that's a more common use case. Creating an instance group is similar to how we created an instance in the first demo. So in Compute, we go to Compute Engine, we go to Instance Groups, and there's already one here created for this demo, but to create one, you just go create instance group, and it's the same process as before. You select an operating system and an instance type, and then you can generate your instance group. So to create the load balancer, we're going to go to our network services, load balancing, and we're going to click create load balancer. We'll go with an external HTTP load balancer. This will route traffic to our service. So we want internet facing. And we can see here, so we have to give it a name. We'll call it test LB. And we're going to do, so backend configuration is going to ask create or select a backend service or bucket. We're going to do backend services. There's one there, but we'll go through the process of creating it. Creating a service, we just give it a name, test service 2, we'll say. Instance groups, we're going to select an existing instance group. We're going to have it set for port 80. And basically default capacity. You can actually add more CPU utilization capacity here if you want, but we'll stick with the defaults. And then we don't need Cloud CDN, but we do need a health check. We'll do a standard TCP health check. It'll do a TCP connection to port 80 to make sure the instance is healthy. And then we click create. And now we've got our backend service configured. That'll also set up our host path and rules, front-end configuration here. Front-end IP, we'll just call it test front-end. We want HTTP. And we'll click done, click create. And just like that, our load balancer will come up. So this is we'll just connect to a set of backend instances, but you can test this yourself if you have a GCP account. Try this yourself, set up a simple web application, maybe a Python Flask app or WordPress, and you can, because there are WordPress images actually, and then you can create a load balancer and connect to it. And there it is. So finally, let's take a brief look at Cloud DNS. So to do that, we just go to our networking section here, and we go to Cloud DNS. And we can see just from the start, it gives us the ability to create a zone. So we'll click Create Zone. We put in some information. We put in a name for the record. We'll call it the example zone. an example DNS name. We'll call it, this isn't what I actually own, example zone.com. We don't need DNSSEC. We don't need a description for now. We're going to make this a public. This is kind of the key decision here. Is this a private zone? Is this a public zone? Do external clients need to be able to look this up? Or is it only our internal GCP services that need it? That's really the question. For this demo, we'll go with public. And then we click create. And voila, we have now our managed zone. And from here, we can add record sets. Click add record set or here. We can do A records, C names, TXT records, whatever we want. This is an A record type, so something like that. We can connect it to some IP address. Yeah, sure, 192.1.1.1, something like that. Create, and we've got a record now for our DNS. So it's really that simple. And that's basically it. So that's our basic GCP network service demo. We covered a few key tools, DNS, load balancing, VPC. This is really just an introduction. Our goal in this course is to get you familiar with the GCP products so that you know which ones solve specific problems. That's the main thing you'll need for the certification exam. Please check out some of our other Cloud Academy courses for a deeper dive on specific features to really learn the ins and outs of each service. Thanks for watching and good luck. So congratulations, you made it. Give yourself a pat on the back. It has been a long and tough ride, but here we are at the end. We went through a lot of material, so before we start popping the champagne and celebrating, let's take a quick minute to just review what we've covered in this course. Now, by completing this course, you should have a working knowledge of how to create an infrastructure plan using Google Cloud Platform. You should know how to design a foundation of storage, networking, and compute services on top of which app developers can deploy their code. Now let's get a little more specific and take a moment to review those course objectives. Objective 1, the student will learn to deploy and configure Google Cloud compute resources and understand the differences between each service. So we did this in section 1 where you learned all about Compute Engine, App Engine, Kubernetes. You should know how to deploy any of these three services via the console or CLI. Number 2, the student will learn to deploy and configure Google Cloud storage resources and understand the differences between each service. This was in section 2. We covered it. We talked about the different storage solutions, including relational and NoSQL, and we discussed their trade-offs. Learning objective 3, the student will learn to deploy and configure Google Cloud network resources and understand the differences between each service. So in the section 3, we covered load balancing, cloud DNS, resource geolocation, network configuration, all of the different resources in detail. You should have enough understanding to cover this objective thoroughly. So with these 3 learning outcomes solidified in your mind, you should now be ready to dig in and build your own infrastructure in GCP. You should also have a conceptual foundation necessary to branch out to other infrastructure platforms, such as AWS, if you'd like. Go you. Now that you're done, I'd like to invite you to send any feedback you have about the course to support@cloudacademy.com. We greatly appreciate your comments, questions, suggestions, whatever you have to say. Congratulations again on fighting through the whole course, and good luck in your future endeavors.